Okay. Dear all, in this session we are going to discuss some of the important topics related to signals and system. So our topic is a very simple topic, that is Integero differential signals and its response. Right. So what is Integero differential signal? So basically we have four Integero differential signal. That is simply our impulse signal, right? Impulse signal, that is del of t, denoted by del of t. Second is step signal, right? We are denoting it by, as usual notation, u of t. And third signal is ramp signal, right? Ramp signal denoted by r of t. And parabolic signal, right? That is denoted by p of t. These are our four basic test signals or reference signal or Integero differential signal, right? So why it is called Integero differential signal? Since one signal can be produced from the other signal just by integrating or differentiating, right? So this is our, suppose I'm representing this by input signals, right? So we have four input signals, right? Now I am writing the output. Output is also called response, right? Response or output due to these signals, right? Now, when suppose the input is an impulse input, either it may be a unit impulse input or an impulse of some step size, right? So our input is impulse, then we call it as impulse response, right? Impulse response. Impulse response have one more name, that is called transfer function of the system, right? So impulse response is also called as transfer function. Suppose our input is a step input, then the corresponding output is called displacement response or displacement output. It is also called position output, right? Or position response or step response. These all are the name for step response, either displacement, position output, or step response. Suppose our input is a ramp input and we can call it as a velocity response, right? Or velocity output. Response and output are same. Or ramp response, right? Ramp response. Now, our fourth signal, that is just dear all, in this session we are going to discuss some important topics from signals and right. So these are our input signals. So when input is an impulse signal, del of t, the corresponding output, we know output is also called as a response, right? Okay. So when impulse is input, this is called impulse response or impulse output. This is also called as transfer function of the system. Okay. So another name of impulse response, that is transfer function. Our next signal is step signal. Step signal is also called position, right? So it is called position output or displacement, right? Displacement output or simply step response, right? Step response. I'm writing it as SR. For ramp input, it is also called as velocity input, right? So input is a ramp input, then the corresponding output is called velocity response or simply ramp response, RR, right? Then another Integero differential signal is parabolic signal. This is called acceleration input. So the response is also called as acceleration response, right? Or simply parabolic response, right? So these are our basic Integero differential signal. I already told why it is called Integero differential. So one signal can be generated or produced by simply integrating or differentiating of other signal, right? Now consider our impulse signal. So you can get the unit step signal U of t from the impulse signal simply integrating the impulse signal, right? So U of t is equal to integral of impulse signal, right? Similarly, we can produce a ramp signal R of t as double integral of del of t, right? Or this is equal to integral of U of t dt, right? Similarly, P of t can be obtained by integrating the impulse signal 3 times, right? Or integrating the ramp signal 1 time. Parabolic signal. Suppose you have step response U of t, right? We have U of t. Now, how can we obtain the impulse signal? That is simply differentiating the step signal. That is del of t is equal to the derivative of step signal, right? Okay. Similarly, we can obtain U of t that is equal to the derivative of ramp signal, right? Similarly, you can obtain R of t by simply differentiating the parabolic signal, right? So this is the relation between these 4 signals. One signal can be produced simply by integrating or differentiating the other signal, right? So based on this, we are going to do some problems. Okay. Now, suppose I have a system. Okay, I'm indicating by this box. Let x of t denote the input and y of t be the response. Right. Now, let this be h of t. Right. H of t will indicate the transfer function. Suppose we know the impulse response. Then how can we find the response corresponding to step input, ramp input, and parabolic input? Can be obtained simply by making use of this property of Integero differential signal. Okay, suppose I am writing input that is equal to some okay, suppose this is our signal and the impulse response. Okay. Now, consider the general model. Suppose a step response of the system, that is, I'm giving the step response of this system that is equal to 1 minus e raised to minus 2t. Now, the question is to find the transfer function of the system. Now, find transfer function of this system. So we know that we can obtain the impulse response from the step response directly by differentiating the step response, right? Now, let impulse response is same as that of the transfer function. Impulse response, that is equal to the derivative of step response, right? So step response is already given, that is 1 minus e raised to minus 2t. So in order to obtain the impulse response of this linear time invariant system, we just differentiate the step response, that is d by dt of 1 minus e raised to minus 2t, right? That is equal to 2 times e raised to minus 2t. This is the impulse response. Now, to find the transfer function, what we have to do? We simply take the Laplace transform of impulse response. That is Laplace transform of 2 into e raised to minus 2t. This value is equal to 2 divided by s plus 2. This is the impulse transfer function of the system. The previous year gate question, right? So options are given. A is equal to 1 by s plus 2. Option B is equal to 2 by s plus 2. Option C is equal to 3 by s plus 2. And our option D is equal to 1 divided by s minus 2. So the correct answer is option B, right? Now, similarly, we can consider another question. I have again a system. Let this is input and we have output as usual notation x of t and y of t. This is our system h of t, right? Now they are given. The impulse response of the system is given. That is impulse response of the system, that is of the above system, that is given as t into u of t. All right, this is the impulse response. And we want to find, now the question is find output for an input of u of t minus 1, right? Okay, and options are given. Option A is t square by 2 into u of t. And option B is t into t minus 1 by 2 multiplied by u of t. And option C is t minus 1 the whole square by 2 multiplied by u of t. And option D is t square minus 1 by 2 multiplied by u of t. So this is our question. Okay. So we have impulse response of the system that is given as t times u of t, where u of t is the unit step signal. Now we want to find the output for an input of u of t minus 1. That is, our input is a delayed step signal, delayed by 1 unit. So we can write our x of t, that is equal to u of t minus 1. And the impulse response, that is given as h of t is equal to t times u of t, right? Now, what is the output corresponding to this input, right? So we have the options. Now, from the impulse response, we can find h of s. What is h of s? H of s is equal to 1 by s square, right? And we know that this is x of x and y of x. So a transfer function y of x by x of x, that is equal to 1 by s square. Right. Now we have y of x that is equal to 1 by x square multiplied by x of x. That is equal to 1 by x square. Now it is a delayed unit step signal. So the Laplace transform of this, that is Laplace transform of u of t minus 1, that is equal to e raised to minus s by s. So we simply substitute here, that is equal to e raised to minus s by s. Or this is equal to e raised to minus x divided by s square. Now simply find the inverse Laplace transform of this signal. So we can find y of t that is equal to L inverse of y of s. That is equal to L inverse of e raised to minus s by s square. The answer of this is equal to t minus 1 the whole square by 2 in multiplied by u of t minus 1. Right. So option C is the correct answer. Hmm. Hmm. Now we can do one more another question. That is, we have a system, right? Okay. Suppose x of t as usual notation our input and y of t is our output, right? Then the impulse response of the system is given as h of t is equal to e raised to minus t plus e raised to minus 2t. Right. Now we want to find the step response. Find step response. This is our question. Right. Now we can write this is x of x, y of x. Right. Now y of x by x of x, that is equal to h of x. Right. Okay. From here, we can find the Laplace transform, that is equal to 1 by s plus 1 plus 1 by s plus 2. We can simplify this, that is equal to 2s plus 3 divided by s plus 1 multiplied by s plus 2. Now, we want to find unit step response. So, our x of t, that is denoted by u of t, or x of x, that is equal to 1 by s. Right. So from this equation, we can find y of s, that is equal to h of s. Instead of h of x, I am substituting the value, that is 2s plus 3 divided by s plus 1 multiplied by s plus 2 into x of x. X of x is equal to 1 by x. Right. Now find the inverse Laplace transform. We will get the response. So for that purpose, I'm using the partial fraction, that is x plus 1 here plus s plus 2 plus the method of suppression. So to find the coefficient of this term, numerator term, you just put s is equal to minus 1 in here. So we will get 2 into minus 1 plus 3 divided by minus 1 into 1 into minus 1, right? For find the coefficient of this, just make this is equal to s is equal to minus 2. So 2 into minus 2 plus 3 divided by minus 2 plus 1. Here, put s is equal to 0. We get 3 divided by 1 into 2, right? So that is equal to, here 2 into minus 1, minus 2 plus 1, 3, minus 1 by s plus 1, then 2 minus 2, minus 4 plus 1, 3, minus 1, plus 1 by x plus 2, plus is equal to 0, 0, 3, 3, 3, 3. 3 by 2 s. So by taking the inverse Laplace transform, we will get, I'm writing here, y of t that is equal to minus e raised to minus t plus e raised to minus 2t plus 1.5 q of t. So this is the answer, right? Madhya. ശരിയാവുന്നില്ല മൊത്തത്തില്